Good morning. Today we have to see one more concept in electrostatics, that is electric potential energy. Electric potential energy. Electric potential energy. Today we have to see one more concept about electric potential energy. The work done against electrostatic force. Work done against electrostatic force to achieve certain configuration of charges. To achieve certain configuration of charges in a given system. Work done against electrostatic force. Work done against electrostatic force to achieve certain configuration of charges in a given system is called as electric potential energy. What is electric potential energy? Work done against electrostatic force to achieve certain configuration of charges in a given system is called as potential energy. Now see, work done against electrostatic force to achieve certain configuration of charges in a given system is called as electrostatic potential energy. SI unit of potential energy, that is work, and therefore SI unit becomes joule. Potential energy that is work done, therefore SI unit is joule, but convenient unit of electrostatic potential is electron volt. Relation between joule and electron volt, that is 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. ही एक रिलेशन लक्षात ठेवा. Actually SI unit of potential energy joule, but in case of electric potential energy the convenient SI unit is electron volt. Relation between joule and electron volt, 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. Okay, now expression of electric potential energy. See, expression for electric potential energy. See, consider a charge plus Q situated at O in air or vacuum. Consider a charge plus Q is placed at O in air or vacuum. Let a small test charge. Let a small test charge, that is Q naught, is situated at A at distance R1 from charge Q. Let B be any point at distance R2 from O at which electric potential energy is to be determined. आपल्याला या पॉइंटला इलेक्ट्रिक पोटेन्शियल तयार करतोय. आपल्याला या ठिकाणी एक सिस्टीम तयार करतोय. मग या दोघांमध्ये असणारी पोटेन्शियल एनर्जी, लेट बी बी एनी पॉइंट at distance R2 from O at which potential energy is to be determined. See once more. Consider a charge plus Q. Consider a charge plus Q situated at O in air or vacuum. Let a test charge Q naught is placed at A at distance R1 from O. B be any point at distance R2 from O at which electric potential energy is to be determined. Then electrostatic force between charges, that is electrostatic force F is equal to 1 divided by 4 pi epsilon into product of magnitudes of two charges, that is Q naught, divided by square of distance between them, that is R square. Square of distance between them, that is R square. This is electrostatic force between these two charges. This force is directed away from charge Q. This electrostatic force is away from this charge Q. Now work done to displace charge Q naught through small displacement dx. Work done to displace charge Q naught through small displacement dr against electrostatic force, that is small work done to displace charge Q naught through small displacement dr against electrostatic force is equal to increase in potential energy, and therefore work done or increase in potential energy is equal to, what is work? That is force into displacement, but this work is against force, and therefore we have to take minus sign. This negative sign indicates that work is done against force, and therefore total work to displace charge from A to B, that is work W is equal to integration of small work dW from R1 to R2. कुठून कुठपर्यंत? R1 to R2. See once more. Consider a charge plus Q is situated at O in air or vacuum. Let a test charge plus Q is situated at A at distance R1 from O. B be any point. Let B be any point along same line at distance R2 from O at which electric potential is to be determined or electric potential energy is to be determined. Then electrostatic force between these two charges F is equal to 1 divided by 4 pi epsilon into Q naught divided by R square. Now work done to displace charge Q naught through small displacement dr against force which increase potential energy, and therefore increase in potential energy or work done, that is F force into displacement. But this work is done against electrostatic force, and therefore we have to take minus sign. This is small work for small displacement, and therefore total work to displace charge from A to B, total work to displace charge from A to B, that is total work or total increase in energy, integration of dW from R1 to R2, which is equal to integration of F into dr from R1 to R2, which is nothing but integration of minus 1 divided by 4 pi epsilon into product of charges Q naught divided by R square into dr from R1 to R2. Value of force कॉन्स्टंट टर्म बाहेर घ्या, इंटिग्रेशन करून कॉन्स्टंट टर्म बाहेर काढा, माइनस क्यू नॉट डिवाइडेड बाय 4 पाय एप्सिलॉन इंटू इंटिग्रेशन ऑफ 1 पाय आर स्क्वेअर इंटू टी आर फ्रॉम R1 टू R2. हित पॉवर आर स्क्वेअर वरती गेलं तर मायनस means integration of r raised to minus 2 into dr. इथं डिनॉमिनेटरला r स्क्वेअर वरती गेलं तर r raised to minus 2. इंटिग्रेशन करून पॉवर 1 न वाढवा, तीच पॉवर खाली घ्या, दॅट इज r raised to minus 1 divided by minus 1. means integration of this term becomes minus q naught divided by 4 pi epsilon into minus 1 divided by r from R1 to R2. Minus becomes plus q naught divided by 4 pi epsilon into 1 divided by R2 minus 1 divided by R1. If suppose R1 is equal to infinity and R2 is equal to R. If suppose R1 is equal to infinity and R2 is equal to R, then this equation becomes 1 divided by 4 pi epsilon into q naught divided by R. This is work done or increase in potential energy, and therefore potential energy U is equal to 1 divided by 4 pi epsilon into q naught divided by R. This is an expression of potential energy. What is electric potential energy? What is electric potential energy? work done against electrostatic force to achieve certain configuration of charges in a given system is called as potential energy. SI unit, potential energy means work, and therefore SI unit becomes joule. But electric potential energy, convenient SI unit of electric potential energy is electron volt. Relation between electron volt and joule: 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. Now, expression of electric potential energy. See, consider a charge plus Q. Consider a charge plus Q is situated at A in air or vacuum. Let a test charge plus Q naught is situated at A at distance R1 from O. B be any point at distance R2 from O at which electric potential energy is to be determined. Then electrostatic force between two charges Q and Q naught. Force 1 divided by 4 pi epsilon naught into product of magnitudes of two charges and divided by square of distance between them. हा झाला force. This force is directed away from charge. Now, work done to displace charge Q naught through small displacement dr against electrostatic force increase potential energy, which is equal to increase in potential energy, and therefore increase in potential energy or work, that is force into displacement. But this work is done against electrostatic force, and therefore we have to take minus side. This is small work or small increase in energy, and therefore total work to displace charge from A to B, that is integration of small work from R1 to R2. नेहमीच्या पद्धतीने इंटिग्रेशन काढा. If R1 is infinity, R2 is R, then this equation becomes like this. This is an expression for electric potential energy. आता हे तर जसं केलंय तसं आपल्याला आणखी एक कन्सेप्ट पाहिजे, ती म्हणजेच इलेक्ट्रिक पोटेन्शियल. वन मोर कन्सेप्ट, इलेक्ट्रिक पोटेन्शियल. Electric potential. See, suppose this one as charge plus Q situated at O. Consider a charge plus Q is situated at O. Then it produces electric field in its surrounding. Let P be any point at which electric potential is to be determined. Okay, now electric potential at any point in electric field. Electric potential at any point in electric field is defined as work done or electrostatic potential energy or electrostatic potential energy per unit charge to displace from infinity to that point. To infinity to that point against electrostatic force. Against electrostatic force. See once more. समजा आपल्याला या ठिकाणी इलेक्ट्रिक पोटेन्शियल तयार करायचं आहे. इलेक्ट्रिक पोटेन्शियल ॲट एनी पॉइंट इन इलेक्ट्रिक फील्ड इज डिफाइंड ॲज वर्क डन or electrostatic potential energy per unit charge to displace from infinity to that point against electrostatic force. Definition: what is electrostatic potential? Electrostatic potential or electric potential at any point in electric field is defined as electrostatic potential energy or work done per unit charge to displace from infinity to that point against electrostatic force, and therefore electrostatic potential is equal to electrostatic potential energy per unit charge or work done per unit charge, and therefore SI unit becomes joule per coulomb, and convenient SI unit is volt. SI unit of electric potential, that is joule per coulomb, or convenient SI unit is volt. This is about electric potential. Now expression. इथं जसं आपण केलं इलेक्ट्रिक पोटेन्शियल एनर्जी, तसंच इथं इलेक्ट्रिक पोटेन्शियल पण तसंच करायचं. सिमिलरली consider a charge plus Q situated at O in air or vacuum. Let P be any point. Let P be any point at a distance r from O at which electric potential is to be determined. Let P be any point at distance r from O at which electric potential is to be determined. Now consider a unit charge, that is Q naught. Magnitude of this charge is 1. Consider a unit charge is placed at m at a distance x from O. हा unit charge है. Then electrostatic force between these two charges 1 divided by 4 pi epsilon naught into product of charges Q into Q naught. But magnitude of this charge is 1 divided by distance square, that is x square, and therefore force between them F is equal to 1 divided by 4 pi epsilon naught into Q divided by x square. This force is away from charge Q. Now work done or potential energy work done or potential energy to displace unit charge through displacement dx against electrostatic force. समजा ह्या चार्ज आपल्याला या डायरेक्शनला डिस्प्लेस करायचं थ्रू स्मॉल डिस्प्लेसमेंट dx work is equal to small work is equal to force into displacement dx, but this force is against work or work is done against force, and therefore total work to displace unit charge from infinity to p, that is work is equal to integration of small work from कुठून कुठपर्यंत infinity to that point r. इंटिग्रेशन आपण कुठून कुठपर्यंत घेतोय infinity to that point r, which is equal to integration of infinity to r work, that is minus f into dx, which is equal to integration of minus infinity to r minus 1 divided by 4 pi epsilon into q divided by x square into dx. जसं इथं आपण इंटिग्रेशन काढलं तसंच परत येता इथं इंटिग्रेशन काढतोय. कॉन्स्टंट बाहेर काढा मायनस q divided by 4 pi epsilon into integration of 1 pi x square into dx from infinity to r, which is nothing but minus q divided by 4 pi epsilon into minus 1 pi x from infinity to r, which is equal to minus minus plus 1 divided by 4 pi epsilon into q into 1 pi r minus 1 pi infinity, but 1 pi infinity is always 0, and therefore work done, that is 1 divided by 4 pi epsilon into q divided by r. This work done per unit charge is called as electric potential, and therefore electric potential phi is equal to 1 divided by 4 pi epsilon into q divided by r. This is an expression of electric potential. See, electric potential is inversely proportional to r, and electric potential energy is inversely proportional to R's. Electric potential and electric field or electric intensity. Electric intensity is inversely proportional to R square, and therefore variation of electric potential or electric intensity with distance like this. हे झालं पोटेन्शियल आणि हे झालं इलेक्ट्रिक इंटेन्सिटी लाईक दिस. this is about इलेक्ट्रिक पोटेन्शियल. ओके, जसं इलेक्ट्रिक पोटेन्शियल एनर्जी आहे तसंच इलेक्ट्रिक पोटेन्शियल ही पण टर्म. आणखी एक आपल्याला छोटीशी टर्म पाहिजे ती म्हणजेच रिलेशन बिटवीन इलेक्ट्रिक फील्ड अँड इलेक्ट्रिक पोटेन्शियल. रिलेशन बिटवीन इलेक्ट्रिक फील्ड and electric potential. Relation between electric field and electric potential. Now consider an electric field. Consider an electric field produced by charge Q, then work done to displace charge through small displacement, and therefore work done to displace charge through small displacement dx, that is small work is equal to minus F into dx. This is small work, but work done per unit charge is called as electric potential, that is dV. Work done per unit charge is called as electric potential, and therefore work dW is equal to Q into dV. This is work, this also work. From these two equations, Q into dV is equal to minus F into dx, and therefore dV is equal to minus F divided by Q, force per unit charge into dx. But electric field is nothing but force per unit charge, and therefore dV is equal to minus E into dx, or electric field is equal to negative minus dV by dx. Thus electric field is defined as the rate of fall of potential with distance. Electric field at any point is called as negative potential gradient, or electric field is nothing but rate of fall of potential or potential gradient. Okay, this is a relation between electric field and electric potential. This is about electric potential energy, relation between electric potential and electric potential energy. Okay, next part on next period.